In this video, we're going to be looking at solving with Pythagorean theorem and classifying triangles with Pythagorean theorem. So Pythagorean theorem is a relationship that we use for a right triangle. So again, just to remind you, for a right triangle means that we have one right angle and two acute angles. We give names to the sides for this triangle. So the two sides that form the right angle we call the legs. And the side that's opposite the right angle we call the hypotenuse. When we use our Pythagorean theorem, typically we like to call our hypotenuse C. That's our longest side. It's across from the right angle. And the two other legs we call A and B. They can go in any order, but typically when we're talking about Pythagorean theorem, C is referring to, we call C the hypotenuse. Our formula for Pythagorean theorem is a squared plus b squared equals c squared. So the relationship between the two legs and the hypotenuse is if I take the leg of one leg squared plus the other leg squared would equal the hypotenuse squared. All right, so when we go ahead and classify, basically if this relationship holds true, that means that this is a right triangle. If it does not hold true, then it is not a right triangle. And then later we're going to look at how to use this relationship to solve for sides of a right triangle. So the first one is saying state if this is a right triangle. We don't, even though it looks like a right angle, we can't assume that it is. So what we do is we identify our longest side, and we can see 15 is our longest side. That could potentially be our hypotenuse. And we're going to go ahead now and substitute this into Pythagorean theorem. So I'm going to assume maybe this is A and B. The hypotenuse is always C, and A and B can be in a different order too. And we're just going to go ahead and substitute that into Pythagorean theorem and see if we get something that is a true statement. So I get here 144. This is 49. This is 225. If I was to go ahead and now combine those terms together, we would get 193. And I got something that was not true. This was a false statement, right? 193 does not equal 225. So I would say that this is not a right triangle. And that's all you were doing. This is actually referred to as the converse of the Pythagorean theorem. So we're applying Pythagorean theorem to test if it's true to classify the triangle. In the next one, we're going to do the same thing. So again, our longest side is going to be our C value. So even though 31 is bigger than 16, root 31 is actually roughly about 5.5. You wouldn't use 5.5, obviously, but just so when you kind of keep in mind, we're not just picking, what always looks like the biggest number, making sure that, root 31, is not the same as 31. Our longest side is actually 16. So we're going to go ahead and name that as our C. The other two I'll name A and B. Any order, it doesn't matter. And then root 31 squared plus 15 squared. I'm going to compare it to 16 squared. Root 31 squared, although it looks scary, is just 31, right? So pretty nice, straightforward. 15 squared is 225. 16 squared is 256. And then when we put that together, we get 256 equals 256. This is a true statement. So what we would say is, yes, it is a right triangle. And that would be it. For the next two, these are probably the ones we're more familiar with. So we're using Pythagorean theorem to solve for a missing side. And we want to make sure that when we're doing it, we're leaving our answers actually in simplified radical form, right? So the first thing we want to do is identify our hypotenuse. Again, that's across from the right angle. So in our number 3, our hypotenuse is actually 10. So when we write this, A and B can be whatever we like, but C has to be 10. And we're going to go ahead now and solve this out. So it just so happens we're solving for a leg. The hypotenuse, though, is always on a side by itself. So we would have x squared plus 64 equals 100. We're going to subtract. To solve for x squared, we're going to get this to be 36. And then when we do the square root, even though we technically would get plus or minus 36 or plus or minus 6, we're talking about a length. We only want the positive answer. So this would be a positive 6. So the length of that side would be 6. For number 4, same thing. I'm going to go ahead and identify my hypotenuse. It happens to be x. And we're going to go ahead now and set up Pythagorean theorem. So this is A, B, and C. And substitute that into Pythagorean theorem. Uh, 169 plus 81. We're going to get that to be 250. We're going to do the square root. And notice it said simplified radical form. So we do have to go ahead and simplify. So 250, the largest perfect square that goes into 250 is actually 25. It's 25 times 10. So we would get here 5 radical 10. And that would be our side length. So in this case, that would be what the hypotenuse is, 5 radical 10. And then we would be done.